So good morning to you all. See, previously we discussed about the molar heat capacity and then units of heat capacity. Okay, so that and all we discussed on previous video session. Here in unit of the heat capacity, if we take U will be equal to Q plus W. In the place of W, we are going to replace it with minus T dV. So which means we get finally Q will be equal to U plus T dV, right? So from that we have to integrate it. So after partial differentiation at the constant volume, constant pressure, and constant temperature, we get the different terms as like, for example, if you take a constant volume, dou u by dou t, at constant volume. Okay, so here this u that refers to internal energy. So now here dou u by dou t at constant volume, again dou h by dou t. H refers to enthalpy. Here this takes place at constant pressure. Okay, so now comes relationship between Cp and Cv for an ideal gas equation. So we all know H will be equal to U plus Pv. Okay, see here this H refers to enthalpy, U in internal energy, P refers to pressure and then volume. So from the ideal gas equation, we know that Pv is equal to nRT. This n refers to number of moles. So now H will be equal to U plus nRT. Okay, so now what we are doing is that the PV இருக்கிற இடத்துல இந்த nRT நம்ம replace பண்றோம், substitute பண்றோம். Substitute பண்ணும்போது என்ன ஆகுது? H will be equal to U plus nRT. So now we have to differentiate this equation. So when we differentiate with respect to temperature, dou H by dou T, dou U by dou T plus N or dou T by dou T. So this gets cancelled and it becomes as 1. So now this is dou H by dou T. So here we have dou H by dou T. See here, this dou H by dou T is nothing but that refers to the, see here, this dou H by dou T refers to Cp. Cp is the constant pressure, takes place at constant pressure. So now we can tell Cp will be equal to Cv plus nR. Okay, so this is dou u by dou t is equal to Cv. So that we get Cv minus Cv will be equal to nR. Okay, so here we can tell that at constant pressure the system has to do work against the surroundings. Hence, the system requires more heat to affect the given temperature at constant volume. So, from this expression, we can conclude that Cp is always greater than Cv. Okay, so this Cv, if you see, it has got negative. So, when compared to this, Cp only has greater value. So now comes the calculation of delta U and delta H. How to calculate it? So if we take a calculation, we can tell, see here Cv. Cv means that refers to the constant volume du by dt. So now du will be equal to Cv dt. So just to cross multiply the dt இங்க multiply பண்றோம். Okay, so multiply பண்ணும்போது we are getting Cv dt. So for a finite change we have delta U will be equal to Cv delta T. So here நம்ம இந்த யூனிட் ஏற்ற மாதிரி இந்த பிளேஸ் ஆஃப் இந்த டிஃபரன்சியேஷன் டேர்முக்கு நம்ம டெல்டான்னு ரீப்ளேஸ் பண்ணுறோம். ஸோ நவ் வி கேன் ரைட் டெல்டா யூ வில் பி ஈக்குவல் டு சிவி இன்டு டெல்டா டீன்றது என்னன்னா டி2 மைனஸ் டி1. ஸோ அதை நம்ம ரீப்ளேஸ் பண்ணுறோம். ஸோ ஃபார் n நம்பர் ஆஃப் மோல்ஸ் வி கெட் n சிவி டி2 மைனஸ் டி1. Similarly, for n moles of an ideal gas, we get delta H will be equal to n Cp T2 minus T1. Delta H will be equal to, this is for delta U. For delta H, it is quite opposite to that. Okay. So actually this and all will be useful for solving the problems. Everything is direct substitution only. Simple, with simple unit conversion we can easily able to attend all the problems. So which will be the easier one without making any hard difficulty in this.